Hello, in this lecture we'll find out the radius of a circle. In the drawing we have triangle ABC. Triangle ABC is a right triangle. Inside this right triangle we have this circle, and our mission is to find out the radius of this circle. In addition, we know that angle ABC equals to 90 degrees. It is a right angle. This is line segment AS that is equals to 1 unit in its length. This is line segment ST that is equals to 3 units in its length. And this is line segment TC that is equals to 2 times root of 3 units in its length. Again, our mission is to find out the radius of this circle. So first of all, we'll define the center of this circle, this point as O. And we'll define the radius of this circle, that is the radius that we are looking for in this question, as x. X is the radius of the circle according to our definition. In the next step, we join points O and S together by a straight line. And we join points O and Q together by a straight line. This is point Q. The point of tendency of tangent BC with the circle. So, what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore OQ is the radius of this circle that is equal to x according to our definition. Here we can implement rule 1. I'll repeat quickly on rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the problem we have a circle, and we have, this is tangent AB. That is tangent to this circle. Here at this point M is the point of tendency of tangent AB with this circle. And we have the radius OM that's equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Can actually create all one in our drawing. In our drawing we have the radius OQ that is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. Line segment OP is the radius of this circle that is equal to x according to our definition. We have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. Whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. So inside this quadrilateral POQB we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus this missing 4th angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing 4th angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral OPBQ to 360 degrees, this missing propagate must be equal to 90 degrees in its size. So inside this quadrilateral OPBQ we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral POQB as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, the side PO must be equal to the opposite side PQ. PO must be equal to BQ. But PO equals to X, therefore BQ must be also equal to X because they are equal to each other. Likewise, according to the same rule, in rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X because they are equal to each other. So actually found out that quadrilateral POQB is not a rectangle but a square. So in the next step, we define the length of this line segment AP as A. And we define the length of this line segment QC as B. In the next step, we'll implement another drawing, rule 10. So, repeat again rule 10. According to rule 10, rule 10 is true in any circle. So we have this circle that could be any circle. And we have the common external point, point P. From the common external point, point P, we have tangent PT that is tangent to this circle at point T. And we have also here chord AB. The extended chord AB touches the common external point P here. So in this drawing, the following equation will be true that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule 10 in our drawing. Why? Because in our drawing, if we focus on this common external point, point A, from the common external point, point A, we have tangent AP that is tangent to this circle here at this point, point P. And we have also the extended chord TS touches the common external point, point A. So all the requirements of rule 10 are satisfied. And therefore, all the requirements are met. And therefore, according to rule 10, we get that AP square equals to AS times AT. Again, AP square equals to AS times AT. So I write it down. I repeat again, if you focus on the common external point, point A, according to rule 10, AP square equals to AS times AT. AP equals to A according to our definition here. Therefore, AP square is A square. And it is equals to AS. AS is 1, according to what is given as the question, times 80. 80 from the drawings is very easy to see that 80 equals to 1 plus 3. Okay, 8 equals to 1 plus 3. So in conclusion, we found out that a squared equals to 1 times 1 plus 3. So a squared equals to 1 times 1 plus 3 is 4, so it is 1 times 4, that is 4. So in conclusion, we actually found out that a squared equals to 4. Here we take a root out of this equation and finally we get that a equals to the square root of 4, that is 2. A equals to 2, so I write the original drawing that a equals to 2. Here a equals to 2 units in its length, that is to say, I say with AP is equals to 8 is equals to 2 units. Likewise, we will implement rule 10 on the common sum point C. Okay. So actually, for the common sum point C, we have tangent CQ that is tangent to this circle here at point Q, and we have also chord ST, the extended chord ST touches the common sum point C. Therefore, all the requirements of rule 10 are met, all the requirements are satisfied, and therefore we can implement here rule 10. According to rule 10, we get that CQ squared equals to CT times CS. Repeat again. According to rule 10, if we focus on the common sum point C, we get that CQ squared equals to CT times CS. So CQ equals to B, therefore CQ squared equals to B squared, and it is equals to CT. CT equals to 2 times root of 3 according to what is given as a question, times CS. From the drawing it is very easy to see that CS in total equals to 3 plus 2 times root of 3. Okay. In conclusion, we should have found out that according to rule 10, b squared equals to 2 times root of 3 times 3 plus 2 times root of 3. So b squared equals to 2 times 3 times root of 3. We'll open the brackets here. This is the equation. Plus 2 times root of 3 times 2 times root of 3 is 12. Why? Because 2 times 2 is 4, and root of 3 times root of 3 is 3, and 4 times 3 is 12. So b squared equals to, here we substitute 12 by 9 plus 3. And we get that b squared equals to 9 plus 3 plus 2 times 3 times root of 3. So actually, this expression 9 plus 3 plus 2 times 3 times root of 3 is very similar to the expression, to the algebraic identity that a squared plus b squared plus 2 times a times b equals to a plus b squared. If you just substitute A in this algebraic identity by 3 and substitute B by square root of 3, we'll actually get that A squared will be equal to A is 3, so A squared is 3 squared, it is 9. We have here 9 plus B squared. B is equal to 3, therefore B squared is equal to 3 squared, it is 3, so we have 9 plus 3 plus 2 times A times B. 2 times A is 3, so it is 2 times 3 times B. B is equal to 3. So 2 times AB in total will be equal to 2 times 3 times equal to 3. Okay, so actually we found out that A squared plus B squared plus 2 times AB equals to 9 plus 3 plus 2 times 3 times square root of 3 if we substitute A by 3 and B by square root of 3. And according to this algebraic identity, A squared plus B squared equals to 2 times A times B. A squared plus B squared plus 2 times AB equals to A plus B squared. It means that 9 plus 3 plus 2 times 3 times square root of 3 will be also equal to A plus B squared. When A equals to 3 and B equals to the square root of 3, and therefore A plus B squared will be equal in total to 3 plus square root of 3 squared. Repeat again, that according to this algebraic identity, A squared plus B squared plus 2 times AB equals to A plus B squared, we get that 9 plus 3 plus 2 times 3 times square root of 3 will be equal to 3 plus square root of 3 squared. And B squared equals to this expression, and therefore B squared will be equal to 3 plus square root of 3 because of the fact that those two expressions are equal to each other. So in conclusion, we actually found out that B squared equals to 3 plus square root of 3 squared. Here we'll take a root out of this equation, and finally we'll get that B equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore B will be equal in total to 3 plus 1.732, that is actually 4.732. In conclusion, we actually found out that B equals to 4.732 units in its length. So I write it down in the original domain. Here, B equals to the length of line segment QC is equal to B is equals to 4.732 units. In the next step, we will implement the Pythagoras theorem on this right triangle, right big triangle, triangle ABC. Okay. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and AC squared must be equal to AB squared plus BC squared. Repeat again. According to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, what is the length of AC? From the domain it is very easy to see that AC equals to 1 plus 3, that is 4, plus 2 times root of 3. So in total, AC equals to 4 plus 2 times root of 3. And therefore, AC square will be equal to 4 plus 2 times root of 3 square. And it is equal to AB square. From the domain, it is very easy to see that AB in total equals to x plus 2. Therefore, AB square equals to x plus 2 square plus BC square. BC, from the domain, it is very easy to see that BC equals to x plus 4.732. Therefore, BC square will be equal to x plus 4.732 square. So in conclusion, we found out that 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. So 4 plus 2 times square root of 3 square, in total it is equals to 4 plus 2 times square root of 3 square is equals to 55.7128, and it's in the other side of the equation we have it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square, that is equals to x square, plus 4.732 square is equals to 22.3918 plus 2 times x times 4.732. This is actually equals to 9.464x. Okay. So in this side of the equation we have 55.7128. In the other side of the equation we have x squared plus x squared is 2x squared plus 4 plus 22.3918 is 26.3918, and 4x plus 9.464x is equals to 13.464x. In conclusion, we found out that 55.7128 equals to 2x squared plus 26.3918 plus 13.464x. Here we subtract 55.7128 from this equation, and we get that in this side of the equation we left with nothing, 0. And in the other side of the equation we have 2x squared plus 13.464x and 26.3918 minus 55 29.7128 is equals to minus 29 point 29.321. So in conclusion, I actually found out that 0 equals to 2x squared plus 13.464x minus 29.321. So here we divide this equation by 2, this quadratic equation by 2, and finally we'll get that 2x squared over 2 is x squared plus, here we have minus 29.321 over 2 is minus 14.66, and 13.464x over 2 is equals to 6.732x. In conclusion, we found out that x squared plus 6.732x minus 14.66 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So we have to put the data of our specific quadratic equation inside this general formula for x in order to find the value of x in our specific quadratic equation. We'll do it now. We'll just copy this general formula for x in a new page. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Repeat again. We just put the data for our specific quadratic equation in this general formula for x in order to find out the value or the values of x in our specific quadratic equation. I remind you that x is the radius of this circle, that is the radius that we are looking for. According to our definition, x is the radius of this circle. So we'll put the data for our specific quadratic equation inside this general formula in order to find out the value of x in our specific quadratic equation. We'll do it now and we'll get that x equals to minus b. B is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 squared. It's actually 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4 times c, that is minus 14.66, and minus 4 times minus 14.66 is equals to 58 plus 58.64 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in conclusion, I actually found out that x equals to minus 6.732 plus minus, inside the root we have 45.3198 plus 58.64. This is actually equals to 103.9598 divided by 2. So I actually found out that x equals to minus 6.732 plus minus, and the square root of 103.9598 is equals to 10.196 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 6.732 minus 10.196 minus 10.196, that is definitely a negative number, and because of the fact that x is a radius and the radius is a length must be a positive number, so the negative solution is the correct solution. We cancel this solution and we left only with the positive solution that is possible for x. According to the positive solution, x equals to minus 6.732 plus 10.196 divided by 2. And minus 6.732 plus 10.196 equals to 3.46 divided by 2. So x equals to 3.46 divided by 2, that is actually equals to 1.732 units. So actually found out that x, that is the length of the radius of the circle, is equals to 1.732 units. And that is the answer to the question. Repeat again. The length of the radius of this circle that is equals to x, according to our definition, x equals to 1.732 units in its length. And that is the answer to the question. In the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. In the drawing, we have the right triangle ABC. In the right triangle ABC, this is angle ABC, that is the right angle. And inside this right triangle ABC, we have this circle. In addition, we know that this is line segment AS that is equal to 1 unit incidence length. This is line segment ST that is equal to 3 unit incidence length. And finally, this is line segment TC that is equal to 2 times root of 3 unit incidence length. Again, our mission is to find out the radius of this circle. So in the first step, we define the center of this circle, this point as O. And we define the radius of this circle, that is the radius that we are looking for in this question, as X. In the next step, we join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle is equal to X according to our definition. Here we implemented rule 1. Why? Because we have the radius OQ that is drawn to point Q, that is the point of tendency BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to X according to our definition. We have here the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Actually, we found out that inside this quadrangle POQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrangle POBQ to 360 degrees, this missing angle must be equal to 90 degrees in its size. So actually found out that inside quadrangle POBQ we have 4 right angles, and any quadrangle that has 4 right angles must be this rectangle, if not a square. So we relate to this quadrangle POBQ with 4 right angles as a rectangle. And we also note that the opposite sides of a rectangle are equal to each other. So in rectangle POBQ, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X because they are equal to each other. Likewise, according to the sum rule, in the same rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X because they are equal to each other. So if you found out that quadrangle POQB is not a rectangle but a square. In the next step, we define the length of this line segment AP as A, and we find the length of this line segment QC as B. Here we implemented rule 10. Repeat quickly on rule 10. According to rule 10, if we have here in the drawing a circle and we have this common standpoint point P. From the common standpoint point P, we have tangent PT that is tangent to this circle point T, and we have the extended chord BA touches the common standpoint P. So in this drawing, the following equation will be true, that PT square will be equal to PA times PB. Again, PT square will be equal to PA times PB. We can implement rule 10 in our drawing. If you focus on this common standpoint point A, from the common standpoint point A, we have tangent AP, that is tangent to this circle point P, and we have the extended chord TS touches the common standpoint point A. So all the requirements of rule 10 are met or all the requirements are satisfied, and therefore can implement rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. Repeat again. According to rule 10, if we focus on the common extent point A, we get that AP square equals to AS times AT. AP is A, therefore AP square is A square, and it is equal to AS. AS is 1 times AT. AT is 1 plus 3. So in conclusion, actually, that A square equals to 1 times 1 plus 3. So A square equals to 1 times 1 plus 3 is 4. So A square in total equals to 1 times 4. That is 4. So A square equals to 4. Here we took out of this equation and finally found out that A equals to the square root of 4. That is 2. So here, let's say with AP is equal to A, it's equals to 2 units in its length. In the next step, likewise, we actually implemented rule 10 in this common example point C. From the common example point C, we have tended CQ to this circle, and we have here code, the extended code ST touches the common example point C. Therefore, all the requirements of rule 10 are met, and therefore we can implement here rule 10. According to rule 10, we get that CQ square equals to CT times CS. Again, CQ square equals to CT times CS. Again, according to rule 10, if we focus on the common standpoint point C, we get that CQ square equals to CT times CS. CQ is B, therefore CQ square is B square, and it is equal to CT. CT is 2 times square root of 3, and CS is 3 plus 2 times square root of 3. So in conclusion, we actually found out that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we open the brackets on this side of the equation and found out actually that B square equals to 2 times 3 times square root of 3, and 2 times square root of 3 times 2 times square root of 3 is 12. So in conclusion, we actually found out that B square equals to 2 times 3 times square root of 3 plus 12. Here we substitute 12 by 9 plus 3, and finally found out actually that B square equals to 12, to 9 plus 3, that is 12, plus 2 times 3 times square root of 3. So this expression, 9 plus 3 plus 2 times 3 times square root of 3, is very similar to the expression A square plus B square plus 2 times AB. And this is actually algebraic identity, that A square plus B square plus 2 times AB equals to A plus B square. If we actually substitute A in this algebraic identity by 3 and B by square root of 3, we get that A square plus B square plus 2 times AB will be equal to exactly 9 plus 3 plus 2 times 3 times square root of 3. Why? Because if A is 3, then A square is 3 squared, that is 9. We have here 9. And if B is square root of 3, then B squared is square root of 3 squared, that is 3. So we have here 3 plus 2 times AB. So it is 2 times A is 3 and B is square root of 3. So we actually found out that A square plus B square plus 2 times AB equals to 9 plus 3 plus 2 times 3 times square root of 3 if we substitute A by 3 and B by square root of 3. And according to this algebraic identity, A square plus B square plus 2 times AB equals to A plus B square. So according to this algebraic identity, 9 plus 3 plus 2 times 3 times square root of 3 will be equal to A plus B square when A is 3 and B is square root of 3. Therefore, A plus B square in total will be equal to 3 plus square root of 3 square. And according to the equation, this expression equals to B square, but those two expressions are equal to each other. Therefore, this expression must be also equal to B square. So in conclusion, actually found out that B square equals to 3 plus root of 3 square. Here we took a root of this equation, and finally found out that B equals to 3 plus root of 3. Square root of 3 is 1.732, and therefore B will be equal to 3 plus 1.732, that is 4.732. In conclusion, we actually found out that B equals to 4.732. So here, This is 970 QC, this is equal to B, and B equals to 4.732. And we already found out that A equals to 2. 970 AP is equal to A equals to 2. Here we implement the Pythagoras theorem on this, the right big triangle, triangle ABC. According to the Pythagoras theorem on the right big triangle, triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on the right triangle ABC, the right big triangle ABC is AC, therefore the square of the hypotenuse is AC square, so AC square must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. AC is 4 plus 2 times square root of 3, therefore AC square is 4 plus 2 times square root of 3 square. AB is x plus 2, therefore AB square is x plus 2 square, plus BC square. BC is x plus 4.732, therefore BC square is x plus 4.732 square. So in conclusion, we actually found out that 4 plus 2 times square root of 3, 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 2 square plus x plus 4.732 square. And here we have 4 plus 2 times square root of 3 square equals to 55.7128, and x plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square equals to x square, plus 4.732 square, that is 22.3918, plus 2 times x times 4.732, that equals to 9.464x. So actually found out that 55.7128 equals to, here we have x squared plus x squared, that is 2x squared. Here we have 4 plus 22.3918, that is 20x.3918. And finally we have here 4x, we have 4x plus 9.464x, that is actually 13.464x. So in conclusion, we actually found out that 55.7128 equals to 2x squared plus 26.7918 plus 13.464x. Here we subtracted 55.7128 from this equation. So in this side of the equation we left with nothing, that is to say 0. In the other side of the equation we left with 2x squared, and 26.3918 minus 55.7128 equals to minus 29.7321, and we have also here plus 14.464x, so I copy it here. So in conclusion, I actually found out that 2x squared equals to 0 equals to 2x squared plus 13.464x minus 29.321. Here we divided this equation, this quadratic equation by 2, and finally found out that 2x squared over 2 is x squared, and 13.464x over 2 is 6.732x, and finally 29.321 over 2 is 114.66. So in conclusion, found out actually that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. This general formula for quadratic equation, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following general formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Another specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient A equals to 1, the coefficient B equals to 6.732, and the coefficient C equals to minus 14.66. Repeat again. In our specific quadratic equation, A equals to 1, B equals to 6.732, and C equals to minus 14.66. So we have to put the data for our specific quadratic equation in this general formula for x in order to find out the value or the values of x in our specific quadratic equation. According to the general formula, x equals to minus b plus minus 4 to b squared minus 4 times ac over 2a. So we put the data for our specific quadratic equation inside this general formula for x and found out the value or the values of x for our specific quadratic equation. And we actually found out that x equals to minus b. B is 6.732, therefore minus b is minus 6.732, plus minus the square root of b squared. B is 6.732, therefore b squared is 6.732 squared. That is 45.3198 minus 4 times AC. Minus 4 times A is 1, so minus 4 times 1 is minus 4 times C, that is minus 14.66. So minus 4 times minus 14.66 is plus 58.64. So in conclusion, I actually found out that x equals to minus 6.732 plus minus 4 to 45.3198 plus 58.64 divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So x equals to minus 6.732 plus minus, inside the root we have 45.3198 plus 58.64, that is actually equals to 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.9598 equals to 10.196 over 2. So in conclusion, I actually found out that x equals to minus 6.732 plus minus 10.196 over 2. So here we have two solutions that are possible for x. The first solution is the negative solution. Why? Because x equals to minus 6.732 minus 10.196, that is definitely a negative number. And because of the fact that x is a radius, and radius is a length must be a positive number. So we cancel the negative solution and we're left only with the positive solution that is possible for x. The positive solution for x is as follows. X equals to minus 6.732 plus 10.196 over 2. That is equal, so minus 6.732 plus 10.196 equals to 3.46 divided by 2. 3.46 over 2 equals to 1.732. In conclusion, I actually found out that the radius of this circle x equals to 1.732 units. Okay, thank you very much.